Here we have a cumulative frequency distribution table showing heights in centimeters of 56 students in Form 4. And the table is completed, as you can see, right? So this is just an explanation as to what each heading is really saying. And so we have the heights of students in class intervals from 149 to 158. That's the range of heights of several students. How many? Well, the frequency tells us that we have 11 students having heights from 149 centimeters to 158 centimeters. And in this class interval, 159 to 168, we have 29 students. In this category, or class interval, we have 14 students. And this one, we have 2 students. Okay, but let's get straight to the problem. We're asked to estimate the mean height. Now, if you notice that there's a heading already that helps us with the process, it's the frequency times the midpoint. The F represents frequency and the X represents midpoint. Of course, they could have given it to you as simply Fx. Fx also means frequency times midpoint. Okay, so even down here you could have had this as well. It really means the same thing. So what we're really going to do, first of all, is understand how did they come up with these numbers. In fact, what really happened is that they multiplied the frequency, the F, which is 11, by the midpoint of this class interval, and they get 1,688.5. The same thing was done for all the others. So this number here came from what? It is a product of the frequency, 29, and the midpoint, 163.5. When you multiply these two numbers, you get this. When you multiply this number by this number, you get this. And by this number times that number, you get this. Okay, so that's how we came up with these numbers. The frequency times the midpoint indicated by X, and the frequency indicated by the F. So now what is this number here though? This says the summation of. Now this Greek symbol, we tend to use this Greek symbol to mean summation. So we add in the result of F times X, each of them. We add in them and we have the sum, which is 9,226. So for the estimated mean, it's really the sum of these values, which is 9,226, divided by the total frequency, total number of students, and we have 56 students. And that is what the mean is. So when we divide that, 9,226 divided by 56, and we have 164.75. Of course, we're talking about centimeters. So this is the mean height, the average height of the students. Now let's look at the modal class. The modal class, what is the modal class? So now for us to get the modal class, what are we going to do is to look at the class interval with the most students. So these are the class intervals. This class interval has how many students? How many students fell into this class interval? 11. What about this one? 29. This one, 14, and this one, 2. So which class interval has the most student? Well, we have 29, which is the most of the frequencies, and so therefore the class interval that corresponds to 29 is the modal class interval. So the modal class interval, right, is the class interval 159 to 168. Simply saying that class interval has the most student. Now, if we look at this histogram was created using the lower boundary and the upper boundary. Let me go over that again. This histogram was created using the upper boundaries in particular. And how do we get the upper boundaries? Well, simply what we did here is that we will take this value, which is the upper limit, and the lower limit of the next class interval, add them, then divide by 2, and we get 158.5. So the upper boundary, let's call this upper boundary here, for this class interval is 158.5. Now this upper boundary becomes the lower boundary for the next class. So put 158.5 here. And these are our lower boundaries. But you might wonder, what is lower boundary for this class interval? We have the upper boundary, but what is the lower boundary? Well, we assume that if we have 149 to 158, we can just assume that there was a previous class to this. Was this starts at 149, so it must have had 148 here. So we add 149 to 148 and divide by 2, we're going to get 148.5. Right? And if you continue, you notice that we have 148.5, 158.5, this will be 168.5, this will be 178.5. So there's always a pattern with these. 158.5, notice that this is 168, so this should be 168 as well. The upper boundary here should be the same here, and the upper boundary here should be the same here, so this should also be 178.5. And of course, this would be 188.5. You can think of it as there's another number here, another class interval that starts at 189. So add 189 to 188, divide by 2, you get 188.5. So that's how we get the boundaries. Okay. All right. So if you look at the histogram, it's created with the boundaries, starting with the very first lower boundary, which is 148.5, and then we go to the next boundary, which is 158.5. Then the next one, which is 168.5. Then 178.5. So notice we'll be using 158 here, 168 here, 178, 188, and so forth. Let's check. 148, which is the first, which is the lower boundary of the first class interval. Then all the upper boundaries after. Right? We just simply add in 10. Notice that there's a difference of 10 units between each boundary. This is what we call the class width or unit size. All right, it's 10. When we subtract the boundaries of respective classes, we get the class width, and they're all the same. Okay, in this case, so the width for this particular histogram is 10 units. Now, but the point I want to make though from this was, how do we get the modal value from the histogram? We'll get the modal value from the histogram. Well, this is what we do. We basically draw a line from the corner of the modal bar here, this bar that's the highest one, and we take this corner and we draw a line straight to the very next bar, the vertex of the next bar here. Then we take a line, another line, and start from the vertex here, go to the vertex of the previous bar, which is right here, and then where they intersect right here, we draw a straight line through, a vertical line through. And where this vertical line hits, which is right here, this is our modal value. Now if you notice this example here, the midpoint between this value and this value, 158.5 and 168.5, should be about here. So this is just a little bit more than that. This modal value is a little bit more than the midpoint of this bar here. So let's go back though. Let's check. So here we have, let me just clear the screen. Here we have the bar we're talking about, right? The modal class. Let's look at that. The modal, the modal class with the most students. This one, 159 to 168, right? The midpoint is 163.5. This value could have been found using the boundaries as well. So if we add 158.5 plus 168.5 and divide by 2, we get the same answer, which is 163.5. Okay? So for the midpoint, we can use the boundaries as well as the limits. Just keep that in mind. only for the midpoint. The width, if you want to find the class width, you must use the boundaries, okay? If you use the limits, you may get a different unit size. So you want to use the boundary for the unit size. So notice that this was, we said was, the midpoint was 163.5. So if we add just one more, we're estimating. So we said add was one value more to that. Then the modal value will be 163.5 plus that extra one onto it is 164.5 centimeters. So that's this is about the estimated modal value. Okay, so if this line had gone just one unit behind this middle value here of 163.5, then we'd have said it probably is about 162.5 or so. If it was like here, then we say it probably is about 160.5 or something. So we're just estimating, a rough estimate, as as close as possible. Okay, so that's with that. Okay, so hope you guys get that. So the modal class interval is this one. The estimated mean is dividing this value by this value. All right, now let's move on now. Let's talk about the median. Let's talk about the median. The median is when we have a set of values. So let's say we have these values here. Let's say we have 7, 8, 10, 12, 13. Where is the median? Notice that we have two middle values, so we're going to add them up, divide by 2, and we get what? We're going to get 11. So this will be our median. 11 would be our median. What if we only have one middle value? Then that would be the median. For instance, we have 7, 8. Let's say we have 13 and 17. What's the median? Well, let's put one more number, odd numbers. We have odd amount of numbers now. So this would be our median. So our median in this case would be 13. All right, so now that we get that, what about the median from a group frequency distribution table, like what we have here? So well, it's kind of hard because we don't have the raw data to help us. So what we'd need to do is to think about the cumulative frequency, what it does. It really positions all the numbers in order of size. So in other words, you see these 11 persons here with heights ranging from 149 to 158. Think of it as we're saying 1, 2, 3, 4 persons. So we're ranking these individuals from 1, right from this. So this person here has the smallest height. Probably is 149 or so, right? Probably 149. This person probably is 149 too. This person is 153. But the point though is that these 11 persons, their height, right, start from 149 and go up to 158. So we're basically saying first, second, third, fourth person, right up to the 11th person. So this is ranking the data, right? The data values, ranking them from first, second. In fact, let me just put the TH on these, right? Third, fourth, right up to the 11th. But notice now, we only have 11 persons in this category, right? 11 persons. This category has how many persons? 29 persons, right? What's the rank of the person with the smallest height in this class interval? What's the rank? Well, this class interval ranks from 1 to 11. So this class interval ranks from what? After 11th person, we have the what? The 12th person, right? Then the 13th person, the 14th person, right up to the what? Not the 29th, no, but the 40th person, right? So in other words, if you count 12, 13, 14 as 1, 2, 3, and you count right up to 40, you realize you have 29 persons in this category here. In other words, from 1 to 11 is 11 persons. From 12 to 40, inclusively, that's 29 persons. Now, this class interval, right, has 14 persons. And the person with the lowest height is the 41st person, right? So the 41st, 42nd, 43rd, right up to the what? The 54th person. And so, and in a similar manner, we have the next two persons would be the 50 what? The 55th person and then the 56th person. Notice that we have these two people here. That's the frequencies 2 for this category. So this category has only 2 persons. Their height ranging from 179 to 188. Could be one person's height could be 179. The next person could be 180 or 180, 182 or so, right? But we're just using the same class width. All right. Okay. Now, so we have these numbers. In other words, 1, right? The first, the second, the third, right up to the 56th person, right? Imagine that we have these numbers aligned, right? The smallest height, right? Let's say starting from 149, right up to the highest height possible, which is perhaps about 188, right? And we're saying that we want the median, the person whose height is in the middle. We have 56 persons, so where's the median will be? So you basically find half of the position, all right? Half of n. So it's half of the number of person, right? The position of the median, half of the persons. We have 56 persons. And that will be 20 to the 28th rank, right? The position of the median is the 28th rank. So the first person rank, this person rank first, second, third, fourth, right up to the 11, etc. Where is this rank? Which category is this rank in? Well, the 28th is in this category here, isn't it? Because this category has persons ranking from 12 to 40. So 28th is actually in this category. So therefore, this category here is our median interval, the 159 to 168. It's a very popular category, isn't it? So the median class interval is the interval 159 to 168. All right, because the 28th rank is the position of the median. You find half, median means, the middle, half of, you find half of the total students, 28th rank student, assuming that they're in order of size, according to their heights, then we find the 28th person, and that 28th person will be in this rank. Let's look at an easier way to get this. But rather than listing them out like that, which takes a lot of time, we go to each cumulative frequency and we ask, have we passed the 28th rank as yet? And once we have passed the 28th rank, that particular value, right, that cumulative frequency value, we check for its in-class interval, and that would be where the median lies. So let's test. So let's test the first cumulative frequency. Is it 28th rank? Have we passed the 28th rank? The answer is no. Let's check the next one, 40. Have we passed 28? Of course, this is 40. So yes, so we have passed it. So that means it's actually in this category. And so that is the median class, 159 to 168. How easy is that?